Hi everybody, hi students. This is a video on mixture problems. And as you can see, this is a photo of a mixture of brown rice and wild rice. We're going to start off with a problem here, probably a little more familiar to you. 10 grams of sugar are added to a 40-gram serving of a breakfast cereal that is 30% sugar. What is the percent concentration of sugar in the resulting mixture? So, what do we need to know? I think really what we want to do here is organize our information in some way, kind of like we organized our information with the motion problems that we did. So, let's put a chart together here. So, what are we doing here? We're taking cereal, we're adding sugar, and we're getting a mixture. It's a mixture of sugar and cereal. Okay, so we've also got our amount of cereal, amount of sugar, amount of mixture, and then of that substance, what is the percent sugar and what is the amount sugar? Because what we're trying to find out is a percent of sugar in the mixture, and it's the amount of sugar that's going to help us to figure out that percent. If I have, it looks like I have a 40-gram serving of breakfast cereal. Let's underline that. A 40-gram serving of breakfast cereal. So my amount of cereal is 40 grams. Okay? And I'm adding 10 grams of sugar. Okay? I'm adding 10 grams of sugar. So those are things that I know. I am adding 10 grams of sugar. 10 grams of sugar are added. Okay. And what else do I know? Well, I know the percent of sugar in the cereal is 30%. Now, if I'm going to do math on 30%, I need to turn it into a decimal. So instead of 30%, I'm going to write 0.30 because that's how we can do math on 30%, is make it into a decimal. Okay, and sugar. Sugar is what percent sugar? Okay, so sugar is what percent sugar? Hopefully I have a lot of you saying to yourselves 100% sugar. Pure sugar is 100% sugar. How do we write 100% as a decimal? Well, we're going to do, let's kind of go over here to the side and say 100%. We're going to do the same thing that we would always do, which is move the decimal over 2 places, is 1. Okay, as a decimal, that is 1. Okay, so that's how we multiply by 100%. We multiply by 1. Okay, and now I've got a bunch of empty spaces that I need to fill in. This is all the information that I'm given, and I've got these empty spaces. Well, under the amount column, okay, I know that if I'm adding 40 grams of cereal to 10 grams of sugar, I know that my mixture here is going to be the weight of both of those combined, which is 50 grams, right? We're adding these together and we get 50 grams. Now, can we add percents together? No, we can't. If we could, it would be easy to solve this problem, but we can't. But we do know, and this is what we want to know, what is the percent of the resulting mixture? So what is this? Right? Instead of a question mark, since it's what I want to know, I'm going to just put an X. It's what I want to know. Now, if I take my amount of cereal, and I know it's 30% sugar, right? It's 40 grams, and it's 30% sugar. If I multiply that 40 grams times 0.3, I'm going to get the amount of sugar, the amount of grams of sugar. It should be roughly a third of 40 grams, so roughly 13 grams. And I multiply 40 times 0.3, and I end up getting 12 grams of sugar. So in my 40 grams of cereal, 12 grams of it is sugar. Now I'm adding 10 grams of sugar, which is 100% sugar, which is 10 grams of sugar, or 10 times 1 is 10 grams. Now, I can do it a couple of different ways here. I can use this information to help me find my missing variable, or I can use this information. I can go either way. So let's go ahead and just multiply across. 50 grams times X percent sugar, right, is 50 X grams. Okay? Now, my amount of sugar, right, that I'm adding is, I'm adding the sugar in the cereal to the sugar that the 100% sugar that I've added, and these are equal. So I can write an equation that looks like this. 12, since this is all grams, plus 10 equals 50x. Okay? Let's do it the other way. I just want to show you the other way. And let's kind of erase this and let's look at it another way. It might make a little more sense to you. I can go ahead and fill the amount of sugar is 12 grams, and I'm adding 10 grams of sugar, so I'm going to get 22 grams total of sugar. And I know that 50 times X equals 22 grams. So I can also use this equation across the bottom. 50x equals 22. And that helps me solve it. That helps as well. So either way it works. Okay, so we divide by 50. Divide by 50, and at this point we do want to pull out a calculator because we want a decimal. We're going to round it off to the nearest hundredth, so that we get a percentage rounded to the nearest 1. And 22 divided by 50 is 0.44. So it turns out that X equals 44% sugar. So when I take my cereal that's 30% sugar and I put 10 grams of sugar on it, I've now got a bowl of cereal that's 44% sugar, almost half sugar. Kind of scary. Anyways, so we've solved the problem. We've answered the question, what is the percent concentration of sugar in the resulting mixture? And we have answered it. It is 44%. Sometimes you'll have different missing information, but you'll be able to set up your chart with what you know and use these equations to help you with what you don't know. Okay? Working down from the amount of the substance, or across on the bottom row the mixture. Okay, we're going to do a different type of mixture problem next. This one is about lima beans and corn. Your favorite dinner, I'm sure. All right, how many pounds of lima beans that cost 90 cents per pound must be mixed with 16 pounds corn that cost 50 cents per pound to make a mixture of vegetables that cost 65 cents per pound? So we want the cost to reflect a balance of what the lima beans cost and what the corn costs, and the different proportions of lima beans and corn. So again, we're going to start off similar to how we started off before. We're going to look at what we're adding together. We're taking lima beans and we're adding corn, and we're going to get a mixture. Okay. This one gets set up a little bit different because we're not talking about a percentage of a substance. We're talking about a price per pound and the number of pounds to get a total cost. So we have our number of pounds, right? Really, we're answering here, how much do we have? And then we have our cost, I'm going to say cost per unit, right? Units could be pounds or ounces. And then we have our total cost. So what does that look like? Let's look at this chart and fill in what we know. Okay. Lima beans. How many pounds of lima beans? Okay, that how many lima beans tells me right away what I'm looking for. X in here for pounds of lima beans. That costs 90 cents per pound. Cost per unit per pound is 0.9. Could put the 0 on or leave it off. Must be mixed with 16 pounds of corn. Okay, so I know I have 16 pounds of corn. That costs 50 cents per pound. To make a mixture, that costs 65 cents per pound. So, okay, so you're thinking, gosh, I've got a lot of blank spaces here. We're going to be able to fill these in just kind of using common sense. If I take X pounds of lima beans and I add 16 pounds of corn, my mixture is going to be 16 plus X. We're just going to use an expression, 16 plus X pounds of the mixture. Those get added. Do I add my cost per unit? No, it doesn't work like that. It would be nice and easy if it did, but it does not work like that. We don't add up the cost per unit. So those do not add. The total cost, though, if I take my pounds, I'm buying 16 pounds of corn at 50 cents per pound. I can multiply the 16 pounds times the 50 cents per pound to get my total cost, which is going to be $8. Okay? 0.5, 1/2 times 16 is 8. And then X times 0.9, I'm going to get 0.9 X for my total cost. It's an algebraic expression for my total cost for the lima beans. And my cost for my lima beans in the mixture plus my cost for the corn in the mixture is going to give me my total cost for the mixture. So I can go ahead, and again, I can do it, I can use, I can do it either way, but let's go ahead then and add these together, right? 0.9x plus 8, and I get 0.9x plus 8 is an expression for the total cost of the mixture. So now I'm going to use this last row to help me solve. I'm going to put this 16 plus x in parentheses because I'm going to be multiplying it by the 0.65. I want to make sure I remember to distribute. 0.65 times 16 plus x equals 0.9x plus 8. So you can certainly pull out your calculator for these calculations. And I have 0.65 times 16, and I get 10.4. 10.4 plus 0.65x equals 0.9x plus 8. Be careful here not to do things in your head with decimals. People tend to make a lot of mistakes. I'm going to subtract 8 first, and I get 2.4 plus 0.65x equals 0.9. And let's see. And I get, I'm going to 0.9x, sorry about that. I'm going to subtract the 0.65x from both sides, 0.65x, and I'll move up here. All right, so I have 2.4 equals 0.9 minus 0.65. Be careful here, 0.25x. So we're going to divide by 0.25, divide by 0.25. Again, be careful with your mental math here if you're doing this in your head, that you're really careful. People tend to make a lot of mistakes working with decimals. So I end up with x equals 9.6. 9.6 what? We are talking about pounds. So let me label it 9.6 pounds. Did I answer my question? It's up here. X, the amount of lima beans. How many pounds of lima beans? 9.6 pounds. All right, so these are two different types of problems. You're going to also see examples in class. You're going to work with your teacher in class to work through these slowly and carefully. But these are examples that are going to help you out along with the examples that you'll have in class to solve these mixture problems. All right, see you tomorrow.